tutorial 2 question 5. Okay, this whole question is a very long question, so I'll just break down into multiple videos to do it. And the first video is actually to let you understand how it actually works. Okay, understand what the hell is this question is talking about. Okay, so the first thing is that a cross-ply laminate made of a unidirectional Kevlar is a pre-preg material, so it's not cured yet. Alright, it's not cured yet, so it's something that you put inside. You put the fiber inside the matrix and then you store it for some time. Alright, and then eventually if you want to use it, then you take it out and then you pour the resin again to cure it together. So hopefully you get what I mean. So the pre-preg material, if you forget, you just go back to your pre-preg videos to check it out. Okay, and Kevlar itself is just Kevlar. So each laminar ply is 1 mm thick, and it's stacked in the sequence of this sequence. So over here there is 4 of them, right? 4 ply, 45, 90, 0 and minus 45. Okay, so in total there is the whole laminate is 4 mm. Okay, so because there's 4 ply. And determine the Young modulus of the composite laminate in the x direction and shear modulus in the xy direction. So it's quite of a don't know what the hell is going on type of thing, correct? So the term cross-ply is the first thing that you don't know what the hell is going on. Cross-ply is itself is just telling you that the ply are being cross-linked, alright, or so-called cross-stacking, okay, all along. Okay, so this is the first layer. Then maybe you have another layer. So when you stack them out all together, they are called the cross-ply laminate. That's just the meaning of that. Okay, and made of unidirectional Kevlar. Unidirectional means that it's strong in one direction. If you were to pull in this direction, you'll break very easily. So it's strong in only one direction. If you have a 45 degrees, then it's strong in the 45 degrees direction. Okay, hopefully this is clear. So therefore, this is a unidirectional Kevlar. And each laminar is, I think this part over here should be fine. Alright, so to the reference x direction. Alright, and so the angle is referencing from the x direction. So if you just visualize, this is in the x axis, this is in the y axis. Okay, so if it's a 45, if you remember, 45 is actually going downwards, 45 degrees. Okay, so this would imply that if this is your ply, your thing is going in this direction, 45 degrees. Okay, that's just the meaning of that. Okay, if it's a 90 degrees, okay, then it's talking about going in this direction, 90 degrees, and therefore your ply would be something like that. Okay, 0 degrees is just one straight line. Alright, it's in this direction, no need to change. Minus 45 is going upwards. Alright, so it's stacking in this direction. Okay, hopefully this is all clear. So in a general view, alright, these are all the plies individually that I drawn, so it's much clearer to actually see. Okay, so therefore they ask you to find the Young modulus and the shear modulus in the x and the y directions. For the Young modulus is x direction. Okay, so they are in terms of x direction, and if you think about it, alright, your laminate is arranged in a different direction, right? Because it's a certain angle. So we can name this certain angle as something. Okay, so this is in the 1 direction, this is in the 2 direction, right? Because you are going in the minus 45 degrees, correct? Then over here, it's 90 degrees. Okay, so therefore this is the 1 direction, this is the 2 direction. This is 90 degrees. Alright, then over here this is 0 degrees, so you don't need to change anything. So the 1 and the 2 direction is the same as the xy direction. Over here this is minus 45 degrees. Okay, and therefore you have something like this. Okay, so this is the 2 direction, this is the 1 direction, this is 45 degrees. Okay, I mean, yeah, correct. So this is the 1, 2 direction. So all the angles that is being specified, alright, they are all in their 1, 2 direction, and it's all in the different 1, 2 as you can see, right? Each of them has different different configuration, and therefore you need to create a transformation matrix in order to transform all this 1, 2 direction, okay, into the XY direction. So you're going to shift it by you're going to shift it by 45 degrees, you're going to shift it back by 90 degrees, you're going to shift it back here and there. Alright, whenever we talk about shifting, alright, or whenever we see something regarding certain stress and strain or any laminar question, straight away you want to know something. That is the reduced stiffness matrix Q. Okay, where you're gonna find this Q first, alright, because you're talking about the certain stresses in the XY direction and tau in the XY direction. Okay, then this is the stiffness matrix Qij, and over here this is the strain in the in the 1 direction, in the 2 direction, and this is the gamma in the 1, 2 direction. Correct? So if you don't remember, it's okay. Alright, now we are going through it now. As you can head back to previous videos, alright, on transformation matrix 5.5, 5.6. I think all of this should be fine. Okay, so this is the first step in order to calculate your stuff first. Okay, so this is not your answer. Alright, this is not your answer yet, but you need to calculate for your stiffness matrix first, because you're gonna find for your stiffness matrix Qij, and then after that you sub it into the transform stiffness matrix. You're going to transform Qij into Q bar ij. Okay, so your first step is to solve for your Qij first. Alright, the second step is to solve for your Q bar ij. Alright, where these are all your Q values. So once this is why we need to find Q first. So once you find the Q, you just sub it in, and then you will get your theta, your angle. So each of the 1 direction, all 1 direction means that it's in the you get what I mean, this is Q11, this is Q12, this is Q12, Q22, etc. Alright, so over here Q11 bar, which is this one, can be calculated by Q11, Q22, etc. Okay, where the Q is also like this. Maybe this is, so you're gonna find this first, and then you sub in this thing into here, sub in this thing into here, sorry, should be this thing, and then you calculate. Okay, so these are all the things that you want to know beforehand. And once you get this, alright, what do you need to do? Alright, the next step, alright, is to get your axial stiffness matrix. Alright, because Qij bar is this one, so you're gonna sum out all the plies. Alright, so what the hell am I talking about over here is that you are calculating a transform. Alright, you are calculating a transform. So what I mean is, you are actually calculating for transformation of this 1, 2 direction into the XY direction, which is over here. So you are trying to transform back into that direction, each for the individual ply. Alright, so this particular step, alright, is to transform all the 1, 2 direction into the XY direction. So this is why it's called the transform stiffness matrix. Okay, as it says, transform stiffness matrix. Alright, and before I forgot, is that if you think about it, this is a 3x3 matrix. Alright, it is taking assumption of a plane stress analysis. Alright, taking that your laminate is a very thin, is a plate, it's a thin plate. If it's a 3D cube, alright, if it's a 3D cube, then it's most likely not this type of formula. Okay, but for simplicity in our school, alright, then this is why they make things simple and make it like a plate. So using it when it's a plate, then you're gonna use this formula. Okay, then once you get this already, you're gonna sum them up all together. Alright, because they have already been so-called shifted into the new direction. All are being shifted in the XY direction already. So once they are in the same direction, then you can add them up together. So you add them up together, alright, which is reflected all over here. Okay, your K is the number of ply. Okay, so you're gonna sum out all the Qij bar, alright, individually. You're gonna sum these things out, alright. Then you multiply with a certain ratio, h divided by n. H is the total thickness of the laminate. If you remember, the total thickness of the laminate it's 4 mm, right? Because each ply is 1 mm, we have 4 plies, so it's in total 4 mm. Our H is actually 4, alright, 4 mm, and then divided by n. N is the number of ply, so divided by 4 plies, and therefore it is equals to 1. So the ratio is equals to 1. So in other words, what we're calculating now is actually calculating for axial stiffness matrix. Alright, meaning now you stack all the plies together. Alright, you stack all the plies with other plies. So there are a total of maybe this is the first ply, this is the second ply, third ply, fourth ply. Okay, and what you're calculating for now, alright, is the stiffness matrix. Alright, in the XY direction already. So you stack them all together already. What you're calculating over here in this whole equation is to calculate the overall stiffness matrix. Alright, it's the overall stiffness matrix. Over here, what you're calculating, alright, individually, alright, is to calculate each of the individual so-called translation. Alright, so you're only calculating for this one, you're calculating for this one, you're calculating for this one, and you're calculating for this one. That's all. Okay, for the QIJ bar. Alright, if you're calculating for QIJ, which is the first step, alright, you're just simply calculating the stiffness matrix at this 2-1 direction, at this 1-2 direction. That's all. Okay, nothing much. So your first step is to calculate this one. Second step, calculate the bar. Third step, alright, is to calculate the AIJ, which is the one that I've just go through. Once you get the AIJ already, then you would sub it into this thing. Okay, so if you think about it, your AIJ is in terms of what? In terms of this thing, A11, A12, etc. Okay, so once you calculate this one, you have all these values already. They are all in numbers. So now, having this matrix, right, then you can sub in over here. Okay, so your A11, you just sub it in. A22, same thing. H is the thickness. I think H is the total thickness of your laminate. Okay, so once you calculate, you will get your longitudinal modulus of your laminate, ELX. Alright, which implies that this is your answer for the Young modulus of the composite laminate in the X direction. Alright, it's in the X direction. So in the X direction, this is LX. LX is in the X direction. Okay, and the shear modulus in the laminate is the GXY, which is this A33 divided by your thickness. Okay, so your shear modulus is this one, which is also the question that it asks. Okay, so it's the shear modulus in the XY direction. As you can see, is in the XY direction, and therefore this is the answer to finding that. Okay, so in a very simple term, you just need to find your QIJ, and then your QIJ bar, your AIJ, and then lastly your ELX and your GXY. That's all. This whole question. The next video, alright, we'll only talk about this calculating for this thing. Okay, because to calculate this, that requires a certain other formulas. Okay, then after that, the next video will talk about the Q bar and perhaps the AIJ together. So the next video is maybe the whole thing together all at once. Okay, so see you in the next video then.